Hi everyone, welcome to Tim and Ronish Academy. Today we're going to focus on a problem we were stuck on in Math 135. And the problem is, a wire 2 meters long is cut into two pieces. One piece is bent into an equilateral triangle, and the other one is bent into a circle. And we want to minimize the total area of both figures. And this is an optimization problem from the real life. And we like to share some general problem-solving strategies in order to deal with it. And first thing you need to do is to define the independent variable and then identify any relationships we have. And using those relationships, we can reduce the equation to one variable, and then we can figure out the function. As soon as we figure out the function, we are able to analyze the function using the first derivative, and before that we need to identify the domain, and then we will solve the problem. And the trickiest part of this problem is the third one, and is to reduce the equation to one variable. And Ronish will explain this in details, and let's welcome Ronish.
Thank you for that wonderful introduction, Tim. Now, if we pay attention to our wonderful diagram that we've drawn out here, now think of the purple line as our wire. If you cut it, we get an x amount or x length of wire, and leftover length will be 2 minus x meters. So in this case, let x represent the perimeter of our equilateral triangle, which is cut from the 2 meter wire, and let 2 minus x, which is the remaining length, be the circumference of our circle. Now let's pay attention to our triangle, which we had the most trouble with. Now, we all know that we want to draw diagrams whenever we do optimization problems in Math 135. However, Tim and I found that we really struggled in manipulating those diagrams in order to get area for our respective triangle and circle. So in order to get the area of our triangle, we want base times height. And in order to get height, we used the sine function as sine pi over 3 equals height divided by x over 3, which is our hypotenuse. And we know the base is x divided by 6 meters. So as a result, you get area of our triangle is x divided by 6 times x divided by 3 times sine pi over 3. Now let's shift our attention to our circle. We know that 2 minus x meters is the circumference of our circle. So using the circumference formula of circumference equals 2 times pi times the radius, we're able to get our radius. Now subbing that into the area formula of pi r squared, we end up with the equation of area equals pi times 2 minus x divided by 2 pi with the entire thing squared. Now finally, the last step is to calculate your total area, which is the addition between your area of your circle and the area of your triangle. From there on, you can take the first derivative to get your critical points, and you guys know what to do from there.